Hello, art and warriors. Today, I'm going to solve question 3 for your response from 2022 AP Statistics. The third question says a machine at a manufacturing company is programmed to fill shampoo bottles with an amount of shampoo that follows a normal distribution. This is the key point, normally distributed, with a standard deviation of 0.04 liters. This is a normal distribution with a mean 0.6 and a standard distribution of 0.04. Right? So we're using the random variable A to represent the amount of shampoo in liters that a bottle contains. Okay, so the part A, the problem defines that underfilled bottle contains at least less than 0.5 liter of shampoo. So we need to find the probability that the amount of shampoo in a bottle is less than 0.5 liters. Since A follows a normal distribution with a mean of 0.6 liters with a standard deviation 0.04, we can use the standard normal distribution to find this probability. So let's calculate the z-score. How do we calculate the z-score? Z-score is just this random variable minus mu over the standard deviation sigma. So this is 0.5 minus 0.6 over 0.04, right? So this is 0.1 over 0.04, which leaves the z-score of 2.5. So this score of minus 2.5 indicates that 0.5 liters is a 2.5 standard deviation below the mean. So let's use the z-table to find the probability corresponding to the z-score. So this is for z minus 2.5, the probability of this happening is, so probability of the bottle X equals 0.05 is about 0.0062, meaning there is 0.62% chance that a randomly selected bottle is underfilled, which is very low. So if I visualize this, we get this follows a normal distribution with mean 0.6. We're finding the probability that this bottle is less than 0.05. So this point is minus 2.5 of z-score. Okay, so again, probability that the shampoo is less than 0.5 is the probability that z-score is less than negative 2.5, which is 0.0262. Okay, so let's move on to part B. So it says after bottle is filled. So let's move on to part B. So this problem concerns with the beauty supply of a warehouse manager who is interested in the probability that the crate will be rejected. So here's a scenario. After filling the bottles, they are placed in boxes, each containing 10 bottles. If 2 or more bottles randomly selected boxes are underfilled, the whole crate will be rejected. Okay, so the first step is to define the random variable of the interest. So this follows binomial distribution because each bottle's fill amount is independent of the others, so the probability of underfilling remains constant. For binomial distribution, we need two things. N equals N, which is the samples. So since each box contains 10 bottles, N is 10. And the probability we just found that the probability of underfilling calculated earlier in the part A is 0.0062. Okay, so using this, let's calculate the probability that the selected bottle is underfilled bottle is greater than 2, greater than or equal to 2. Okay, so this is same as 1 minus the probability that the underfilled bottle is less than -1, less than or equal to -1. So what is this? To calculate this, we need to find the probability that X equals 0, which is underfilled bottle is equal to 0. We are choosing 0 from 10 and the combination, and from 0.0062, 0 to the 0th power, and 1 minus 0.0062 to the 10th power. Okay, we do the same for the probability that the underfilled bottle is 1. So we choose 10, we choose 1 from 10, and 0.0062 over 1, and 1 minus 0.0062, 9. So this is about 0.9397, and this is about 0.0586. So adding these two gives about 1 minus 0.9983, which gives us 0.0017. So this is the probability that the crate will be rejected by the warehouse manager. So now let's determine the probability that a crate will be rejected by the house manager. So we just found, we'll go here, right? So this we just found 0.0017. This is actually the probability that the crate will be rejected. This is the probability. Okay, then last one, the part C, which asked whether the manufacturing company should stick with the original programming of the filing or adjust it. So reduce the number of crates being rejected. The company is considering adjusting the filing machine so that the amount of shampoo in each bottle follows a new normal distribution with a mean of 0.56 liters and reduced standard deviation of 0.03 liters. Okay, so let's calculate the z-score of this. So z-score here, this one is 0.5 minus 0.56 over 0.03, which gives us 0.06 over 0.03, which is -2. The probability of having z-score minus 2 is about 0.228, which is about 2.28. So this probability is significantly higher than the 0.0262 chance under the original setup. So this means that the original, with the adjusted program, there should be a greater likelihood of bottles being underfilled, so leading to more rejected crates. So therefore, the company should stick with the original program, right? Stick with the original programming. So this was our walkthrough, and hope you found this walkthrough helpful. And if you have any questions, please leave them on the comment, and I'll see you in the next video. Thank you.